additive property of inequality with whole numbers. So you're starting to get into solving inequalities. Now, for the most part, inequalities get treated the same way that equalities do. There are some key differences that you're going to run into when we talk about the multiplicative property, but for our purposes right now, this statement 15 greater than w minus 2 can be solved as if this inequality symbol were an equal sign. Now, I do not want you taking inequality signs and putting them in as equal signs. If you change it in the middle of your work to an equal sign, you're going to get completely messed up when you go to give your answer. Another thing I want to mention is that the instructions on ALEKS are a little different than the instructions I've given here. The reason I've given the instructions this way to graph it and then give your answer in interval notation is that's how we're going to be asking for your answers on the test. So even though ALEKS isn't asking for you to give your answers that way right now, it's important that you know how, and I want to reinforce that in this video. So solving this guy right here, solving it just the same way we would solve inequality, trying to get w by itself, I would want to add 2 to both sides. Right? And you can treat it as if there's the wall right here. That's where the equal sign would be, so the inequality is kind of like the equal sign here. Those 2's will cancel. 15 plus 2 is 17. Right? We have this inequality symbol, and then it's just w. So we have 17 is greater than w. Now, most people don't like to see inequalities written with the variable on the right-hand side as opposed to the left-hand side. This is the same statement as w less than 17. So if 17 is greater than w, that means w is less than 17. But the way that I like to think about it, when you go to rewrite it with your variable on the left, just make sure that you're consistent with what this is pointing to. So this is pointing to the w, the inequality is pointing to the w, so when you rewrite it, it's still pointing towards the w. So they can be rewritten, and this is the way that we're more used to seeing. On the number line, I don't have 17 down here. Let me just go ahead and erase that. Delete. And I'll make my own number line. I'm just going to plot 17 right here. I'm going to give it an open circle because there's no underline on the inequality, and I'm shading everything less than it. Now, writing it in interval notation, negative infinity is down here, positive infinity is up here. So you would need to know how to write an interval notation, and if you don't know how to write an interval notation, you should look at the topic. It's called, flip through some papers here, it's called Set Builder and Interval Notation. So look up the topic. I may link this in ALEKS. No, I'm not going to do that. It's going to confuse people. So I'm not going to link this topic in ALEKS within the topic you're on right now, but you can search and look for this topic. It'll show you how to write an interval notation. So hopefully you've already done that topic. In interval notation, reading the highlighted part from the left to the right, we're starting at negative infinity. We put a comma. We go all the way up to 17. Now, infinities will always get parentheses, and because there's no underline on our inequality, 17 will get a parenthesis as well. So this is our interval notation answer. As a quick reminder, if you have an underline on your inequality, that's going to translate to closed circles on the number line, which will translate to brackets in interval notation. If you have no underline, that will translate into an open circle on the, so if you have no underline in the inequality notation, then it's an open circle on the number line, which is parentheses in interval notation. Let's go ahead and do a few more. All right, let's look at the example. Z plus 6 is less than or equal to 24. So I want to get Z completely by itself. That means I am subtracting 6 on both sides, just like I would do with a regular equality. The z comes down, the inequality symbol comes down. 24 minus 6 is going to be 18. So we have z is less than or equal to 18. If I draw a number line and plot 18 wherever I want, I know that there is an underline on this inequality, so I am doing a closed circle, and then I want to shade the numbers less than 18. For my interval notation, the highlighting starts at negative infinity and goes all the way up to 18. Infinities will always get a parenthesis, and then because we have a closed circle, we will get a bracket on the 18. So it's not so bad. This topic is not that bad. Just one more. Here we have 16 is greater than or equal to y plus 9. I want to get y by itself, so I'm subtracting 9 on both sides, which will cancel those 9s. 16 minus 9 is going to give you 7, greater than or equal to y. Now, once again, we don't really like to see this as 7 greater than or equal to y. We want y to be on the left-hand side. So notice that it's pointing towards the y right now, which means when I rewrite it, it should still point towards the y. So 7 greater than or equal to y is the same as y is less than or equal to 7. On my number line, here's 7. It gets a closed circle because there is an underline in the inequality, and then shading to the left of it will give me all the numbers less than 7. Negative infinity is down here. So we start at negative infinity, we go to 7, parentheses on infinities always. 7 has a closed circle, so he's going to get a bracket. And that's all there is. So really, really important here is that, where's my pointer? There it is, and that you have this guy memorized right here. And that you know how to do interval notation and how to graph things on number lines. This topic right here is really just, they're having you answer with just this part here. So this topic itself isn't that bad, but I really, really encourage you to do this piece on your own because it is a really important part. So you're doing great. Remember, this is how we're testing you on the test. You need to be able to do this, so please do that. And I hope you have a great rest of your day.